Last time we saw how to set up hypothesis testing. So there are three ways you could, set up. One is called two-tail. Um, so if it is two-tail test, you have to have a not equal sign in your alternate hypothesis, right? So this is two-tail. For the right tail test, you have to have a greater than sign. For a left tail test, you have to have a less than sign in your alternate hypothesis, right? Okay, let's move on to next definition. Okay, so now this is our entire picture of our hypothesis testing, figure 8.2. So look at here. There are several cases there are, of course, four cases here you see, right? Suppose you have, for example, suppose if you have two testing hypotheses, okay? For example, say H naught and H1. So say my H naught, for example, say mu is some value, say 50. Say my alternate hypothesis mu is say two-tail test, say not equal to 50, right? So if you have like this one situation, so now what does mean by this scenario? This scenario says that um, you know when H naught is true, you are rejecting H naught. You are telling that H naught is not correct, right? But actually it was correct answer. That means if you make such a mistake, right? So you are making a mistake. H naught is really true, but you are rejecting H naught and you are accepting your claim, right? Remember, this is my claim, right? Alternate hypothesis is my claim. So H naught was really correct, but according to your, the work here you did, and you came up with the decision that you are rejecting H naught, but actually it was true. These type of mistakes are called the type 1 error. Okay. While H naught is true, you are rejecting H naught. Okay. When H naught is false, if this is false, that means so if it is false, you have to assume your claim is correct, right? That means if H naught is false, you are rejecting H naught. Yes, there is a correct decision, right? If you look at here, you know that H naught is true. You do not reject H naught. Yes, this is true. Therefore, I am accepting that. So this is also my correct decision, right? But look at this guy. You know already H naught is not correct, right? But still you are not rejecting H naught. Even though this is not correct, you are accepting that. That means this is also going to be kind of mistake you are making. So this kind of error is called the type 2 error, okay? So only you have to look at these two errors when you do hypothesis testing. So the type 1 error means what? You are rejecting H naught when H naught is true. Type 2 error, you do not reject H naught when H naught is false, okay? So keep in mind these two. So if you look at next one, these all given in words, whatever we have there at the top in the picture. So it's just about the picture they are explaining in words. Okay. Now, yeah, these two are coming from your picture. Now look at this one. The level of significance is the maximum probability of committing a type 1 error. Okay. So the level of significance will be given in the problem. Okay. So we denote that by alpha. Okay. So the alpha is nothing but the probability of making type 1 error. What is the chance of making type 1 error, which is called by alpha? This alpha is nothing but the level of significance. This will be given in the problem, of course. Alpha is known. Okay. Do you hear me?
Yes.
Yes. Okay, so that is one definition of the Greek letter alpha. In similar way, the probability of making type 2 error is called by beta. So beta is nothing but the probability of making a type 2 error. Okay. Right. Now let's move to the next definition here. The critical or rejection region. A critical or rejection region. What does mean by that? That means, suppose you see you have a particular test. Say I have say I have a right tail test. Okay. So if you have a right tail test, of course you know that you will have the things are here, right tail test, right? Okay, suppose if you have right tail test, what does mean by rejection region? Region means you will find first one value here. This value is called the critical value. This value is based on your significance level, right? So this is based on your alpha. So you will be given alpha. Once you know the alpha, you know by using the table, z distribution or kind of table, you will figure out this value, right? In z distribution, you will have here z value. You know the table, right? Suppose if you know alpha, that means the area, right? This side area. Suppose if you know this alpha here significance level, then you know how to find the critical level, critical value, right? Once you have the critical value, this region, right? This region, this region is called the critical region, critical or rejection region. Okay. So the critical region or rejection region is found by looking at your alpha. Alpha is given by will be given in the problem. Okay. Whatever left over here, this is called the non-critical region, right? So this is called a non-rejection or a non-critical region. That is a non-rejection region. Okay. So this value is called the critical value. So we use, the abbreviation C dot V for critical value. Okay. So these are kind of definitions. We will look at one example, then you will understand these statistical terms. Okay. So here we have taken one example about the critical region. You see here for the right tail test. Okay. How do you find the critical region? Look at that. You are given alpha value, right? The significance level is given 0.01. Okay. So now the problem is right tail test. Therefore, this area should be alpha 0.01, right? Suppose say this is a z distribution problem. If it is z distribution problem, you know how to find this guy, right? This is called now critical value. You can see. How do you find that? Look at the table. You know the area, right? Remember, if you want to find the z value, you have to plug in the left area to that point. So right area is 0.01. Therefore, the left area is whatever left over this side, right? So the left area to this point is nothing but, what is that area? You have to subtract 0.01 from 1, right? That means you will get 0.99. So that is the area of the left side. So you have to look at this value in your table. Then you will figure out that corresponding z value, right? So if you look at your table and you will find that the area is 0.990, so 0.990 will be somewhere, where should be somewhere here, right? 0.990990, right? 9900, yes. So which one is the closest one to 9900? So you will see this one is the closest one, right? So that is 2.30123. 2.33, right? Therefore, the critical value for that area is 2.33 roughly. Sorry, roughly. So you see here, that's why it is 2.33. Okay. Therefore, the critical value Z here in this problem, this C is 2.33. Okay. So if it is left side area, again, because of the symmetric, you will get negative 2.33, right? Okay. Now, if it is two-tailed test, follow the same procedure. If you know alpha, say alpha is 0.01 again, but now this is two-tailed test, right? So that means you have to divide this alpha by 2 to get the one-side area. So this is nothing but alpha over 2 because you have this side also, right? So this also alpha over 2. So if alpha is 0.01, then alpha over 2 is 0.005. Again, do the same procedure and find out the corresponding critical value Z. Okay, these are kind of, the practice to get a critical value, right? Okay, so now how are we going to, test our hypothesis? These are the steps we are going to follow. First, you have to set up your hypothesis, right? H0 and H1. Now find the critical value from the table given. So you may have a t distribution, z distribution, or chi-square distribution, whatever it may be. So first find the critical value like this, right? After that, you need to compute the test statistics. This is called the test statistics. Okay, this test statistics is calculated by what? By looking at your sample. Okay, so you are using sample, right, to check your claim for the population parameter, right? So you are given a sample, use that sample to find out the test value. Test value is called the test statistics. You will be given formula for each case, okay? Use the formula and plugging your sample values. Samples means what are the values you will have in your sample size or sample actually. In sample you may have X bar, right? Then you will have a standard deviation sample. These are the things you will calculate, right, when you have the sample. So you will figure out those values and find the test statistics. Once you have the test statistics, make the decision whether to reject or accept your null hypothesis. Null hypothesis means H naught, right? So you will, check the decision by looking at your test statistics and the critical value, whether to reject your H naught or not. Then once you have the rejection, the decision, and you will summarize the results. So these are the procedures we follow here. Okay. Okay. This is about the p-value method for testing hypothesis. Let me tell one thing. When you test a hypothesis, we follow two methods. Okay. You could use either method. The first one is called the traditional method. The second method is called the p-value. Okay, so let me explain these two first. Then after that, we will look at. So this is the very common method people use, the traditional method, right? What does it mean by traditional method? First, you will set up a hypothesis, and according to that, you will draw a picture, right? Like that. For example, say my testing hypothesis is a right tail test. So you will have the area here. Now, for example, say my distribution is Z, then we know now how to find the the critical value Z, right? That we call this as a Z alpha. This is my significance level will be given in the problem alpha, right? Okay. So now the thing is, this is my critical value. Let me call this as C dot V. How are we going to take the decision whether to reject H naught or not? This is the way. First, find the critical value, then find your test statistics. Okay, so you'll be given formula, so you will find this value. This is just a number, okay, just a value. So say this value is, I don't know, say C1. Now the thing is, if this value is falling in this region, remember this colored region is my rejection region, right? Suppose your Z1, say Z1 is somewhere here. If your Z1 is coming or falling in this region, then you have to reject your hypothesis H naught, right? If your Z value is here, then reject H naught. Then I will reject H naught. That means what? That means we accept our null hypothesis H1, right? Suppose your test statistic says Z1 is somewhere here. If your Z1 is somewhere here, then this is my non-rejection region, right? If your Z1 is on a non-rejection region, then you do not reject H naught. So according to your test statistics, you will either reject or accept, the null hypothesis. So this is called the traditional method. Only thing is you have to figure out the test statistics and the critical value. Okay? But here, the p-value is for the p-value problem, we don't find the critical value. We don't want critical value, okay? Critical value, we don't want that. What do you want to do? You want to find the test statistics like this. First, find the test statistics for the problem. Say, suppose if the test statistic is, say, Z1, right? First, find the Z1, okay? Once you have the Z1, then we will figure out the p-value. P-value is nothing but the area of your region. This is p-value means actually the probability of for your test statistics being in this region. Okay, so we will find the p-value. So p-value is nothing but just simple value, just a value, simply the area of this region. We know how to find the area, right? Suppose if this is a z distribution, look at the z distribution table and find this area, right? You know this value, right? What is this Z1? Z1 is my test statistic, right? Once you know the test statistic, then you know this value. Then by looking at your table or calculator, you could find this area, right? If your area, this little p or big P, whatever may be, if this value is less than your significance level alpha, or you could include equal sign, right? If your p value is less than or equals to the significance level alpha, then you have to reject your null hypothesis. If the p value is bigger than the alpha, then you do not reject. So we will do one example from each case, okay? Right? So these are the two methods we use. So you could use either way, but most of the people use a traditional method, okay? So this is the way to figure out whether to reject or not, okay? So that's about the p-value. So the p-value is the probability of getting the sample statistics, mean test statistics, right? Or more extreme. More extreme means so your test statistics may be the probability of being your test statistics in this region. That's the meaning of this. Okay, right. Okay, so let me do, okay, this problem already they are in your note. So that is similar to this problem, okay? So I'm not going to, this is the similar one, right? Okay. So I'm doing one problem. So let's do number 5. What is the question? Using the Z table, find the critical value for each problem. You are given significance level alpha. So I'm doing number 5. For number 5, my alpha significance level is 0.05. They are telling that the test is right tail. Okay, so let's draw the picture. The problem is about the Z distribution, right? So let me draw a picture. So now the problem is a right tail test. So that means you have to have the area in the right side. This is my Z, right? Remember, this value is my critical value. You need to figure out that value. So what is this area? This area is nothing but alpha. That is a 0.05. Okay, so you could find the critical value, right? Okay, so you could use the table. If you want to use the table, you have to plug in the left area to this point, right? Um, then figure out, or I'm using the calculator. Let's use the calculator. So you have to use the inverse norm function, right? Use the inverse norm. Since this is Z, so that is standard normal. You have to plug in the left area. So what is my left area here? Would you tell me? Any one of you? What is left area? This side area.
Would it be 0.95?
0.95. Very good. 1 minus 0.05. So that is 0.95. So this area is 0.95. So use the calculator, inverse norm function, and the left area is 0.95, right? That's it. You don't need to put mu and the sigma here because for the standard normal, the calculated default value is 0.1. If it is not 0.1, then you have to plug in those values. So, but this is enough, right? So let us use the calculator and find the critical value. Then so clear this, and I'm using the second var, and the inverse norm is number 3. And I'm going to type my left side area to that point, which is 0.95. So it is given 1.64, right? Therefore, my critical value is 1.64. So this value is 1.64. Okay, so like that, you could do all the problems, right? So if it is two-tail test, you have to divide the alpha by 2 and plugging those two values in your let me draw a picture, then why don't you go try later? So this is two-tail test, right? That means you will have both side area. So now the alpha was 0.1. So if you divide by 2, you will get this area alpha over 2. So which is what's that, 0.05, right? So this side also 0.05. Now how many critical values you will have for this problem? Would you tell me? Where are the critical values? Critical values are now two values, right? One is here and one is there. Let me call this as Z1 and this is Z2. Because of the symmetric, you will have the same answer with the opposite sign, right? Here you will get the negative and here you will get the positive. Okay? So find out that value. So what is that value? Exactly the same value you will get, right? This value you will get. You know why? Because this area is now 0.05, similar to this problem, right? Therefore, this is inverse. Okay. 2 is inverse no 0.95. So this is 1.64, and that should be negative 1.64, right? Because of symmetry. Okay, so these are the ways to find the critical values. Right. Now here, let me do here also two problems I'm going to do. For each conjecture kind of claim you are making, state the null and the alternate hypothesis. Like last time we did, you have to set up two uh, statements, right? H0 and H1. Okay, so let's do number 1 and number 2. Okay, so could you set up a hypothesis here for the first one? The average weight of dog is 15.6 pounds. Then what is your H0 and H1? Let's see who's telling. What is the population parameter they are talking about? Yes, they are talking about the average, right? Therefore, there is going to be population mean. So we are suspecting whether the mean is 15.6. Therefore, my alternate is going to be not equal to 15.6. Number 2. The average distance a person lives away from a toxic waste site is greater than, okay, so this is going to be your claim now, right? Remember, conjecture means your claim. So claim is going to be your H1. Okay, so now here we are suspecting whether the average distance, therefore average, again they are talking about the population mean, but now it is greater than 10.8. So this is going to be mu is equals 10.8. Like that, you need to figure out all the hypothesis testing. Okay. So the first one is a two-tail test, and the second one is a right tail. So if you have any question, please ask. Right. Now here, it's very simple. You don't need to do anything. Just write your answer. Remember, I told you, how are we going to use the p-value to decide whether the null hypothesis is rejected? Recall? Just now I explained, right? Only you have to look at the p-value. P-value is the probability value. If this is less than or equals to alpha, then what do you want to do? You need to reject H naught. If the p-value is bigger than your alpha, then what do you want to do? Then do not reject. Okay, so this is the thing you have to keep in mind. Use these two conditions and do one by one. What are you going to do for the first one? Alpha is 0.05, right? P-value is 0.0443. Which one is correct? First or second statement. Your p-value is now get smaller or bigger than alpha. This value? Yes? Of course, this is smaller than alpha, right? Your alpha is 0.05 and your p-value is 0.04. This guy is smaller than this. Therefore, what do you want to do? You need to reject. Look at here. Which one is bigger now, alpha or p-value?
P-value is bigger.
P-value is now bigger, yes. The p-value is now, this guy is bigger than 0.01, right? Therefore, we do not reject. Next one. Which one is bigger? Again, p-value is bigger, right? This guy is bigger. So again, this also p-value is bigger. So do not reject H naught. The last one, of course, p-value is smaller than alpha. Therefore, I reject H naught. Okay. Now this is all for you. Why don't you try later? Okay, so this all about now in in section 8.1. So we have kind of introductory things, right? So now we know how to find the critical value, we know how to find the critical region, then you know the procedure about how to reject the how to reject your null hypothesis based on traditional method or maybe in p-value. So now we are going to apply these techniques to to specific problem, right? Okay, so now let us move on to 8.2. 8.2. Now we are going to use, testing for the mean. Okay, that means what? That means our null hypothesis and alternate hypothesis talks about the mean, population mean. Okay, for this kind of problem now, for the testing mean, there are two cases now, like we had in a confidence interval for the population mean. Remember? So we had two cases there, right? The standard deviation, population standard deviation, little sigma is known or not. Here also we have two scenarios to find the the test statistic, right? The first case is when sigma is known. If you know the sigma for the problem, your test statistics for this kind of testing mean is this, right? So my test statistics, I'm writing now here after test stat for test statistic. Okay, this is now, if you know the sigma, this is simply x bar minus mu over little sigma over square root n. Remember, this is just a value, right? These all the values, x bar, little sigma, and the square root n. These all will be given in the problem. Remember this x bar, and this little n. These two coming from where? These two coming from your sample, right? X bar is sample mean and little n is your sample size, and this little sigma is the population standard deviation, and this guy mu is coming from where? Coming from your H naught, your null hypothesis. Look at your null hypothesis, look at your mu value, then plug in that value here. Okay, now this is called the test statistic. Okay, let's see now how to perform the test. Again, we have the assumption here, like the confidence interval problem. Our assumption is that the sample is a random sample, and you need to have this condition. The sample size should be bigger than or equals to 30, right? In general, if you do not have this condition, then your distribution should be normal, right? Either one should satisfy. But throughout these problems, the testing hypothesis, we assume that these two conditions are satisfied. Okay. Now these are the steps. Again, we are recalling. Step one: write your, the hypothesis, find the critical values, then compute your test value, then make the decision about your, about your H naught, whether to reject or not, then summarize your results. Okay. So one problem is here already worked, and I have shown you. So let me explain about this. A researcher believes that the mean age of medical doctors in a large hospital system is older than the average age of the doctor in the United States, which is 46. Assume that the population standard deviation for this problem is 4.2. So you know the population standard deviation. The random sample is now 30, right? You know the significance level, right? So now the mean age of the sample, that means what is this guy? You have a lot of numbers now. So you need to identify each and every number here, right? If you look at the problem, remember your claim is based on your population parameter, right? Now in this section, we are talking about the mean. That means our population parameter is now mu. So we are setting up the hypothesis testing for mu, right? That is why if you look at here, your null hypothesis is mu is equal 46. So this is your null hypothesis value 46, right? But remember, if you look at here, the researcher believes in the sense that this is his claim, right? His or her claim. The claim is what? He or she believes what? The average age is older than the average, right? Older than the 46. So older than in the sense greater than. That is why we have, my claim is here, right? Your alternate hypothesis is mu, which is bigger than 46. Okay, so your null hypothesis is 46. Now the thing is we have to figure out these numbers, right? What is this 4.2? That is the population standard deviation. Therefore, little sigma is 4.2. And what is x bar here? Sample mean, average of the sample. The average mean age of the sample is 48.6. Therefore, x bar is 48.6. Alpha is known. Alpha is 0.05. What else? Little n, the sample size is now 30. That is here. Then I have all the numbers, no? Okay, so now draw a picture. What kind of test I have now? My testing hypothesis says that I have now right tail test. Therefore, you have here the area. So this is going to be my rejection area, right? So this value is going to be my critical value. How do you find the critical value? By looking at your alpha. This area is now alpha. What is my alpha? Alpha is 0.05. Just now we did, right? For 0.05, what is the critical value we got? 1.65. Right? Therefore, my critical value is 1.65. Right. Now let us calculate our test statistics. How do you find the test statistics? You use the formula I explained earlier. I'm using which formula? I'm using test statistics formula, x bar minus mu over standard deviation over square root 10. Use that formula. You know all the numbers now, right? Simply plugging all the values here and simplify that value. That is going to be my test statistics. So if you plug in those value here, x bar is 48.6 and subtract the mu. Mu is coming from your null hypothesis, which is 46. Then divide by the standard deviation, which is what is standard deviation, which was 4.2 over square root, little n is 30. Simplify this, you will get one number, right? That is 3.39. Okay. This is nothing but z value, right? 3.39. Remember, my critical value, let me pick one different color to check here. Right. This is my critical value right over here. Bless you. This is my critical value, 1.65, but my test statistic value was 3.39. 3.39 should be somewhere here, am I right? Because 1.65 is here, critical value. My test statistic Z is 3.39. It is somewhere here, right? Obviously, my test statistics is now falling into a rejection region, am I right? So test statistics is falling into rejection region. Therefore, what is your decision? Your decision is rejecting your null hypothesis because of your test statistic falls in a rejection region. Therefore, to make the decision, my decision is to reject the null hypothesis, H naught. You are rejecting H naught. Reject H naught, right? What does mean by that? You reject H naught. Reject H naught. So you reject this. You don't know this is not correct. That means your claim is now valid, right? So this is your final answer, summarizing your results. Now you know that your claim is correct. Summarize the results. There is enough evidence to support the claim. Your claim is now correct, right? What was your claim? Your claim was the average age of the doctor system is now greater than 46. Yes. Therefore, you accept your claim. That is correct. Okay. So this is the way to perform hypothesis under statistics. So I believe you understand. So if you have any question, please let me know before going to start the second exam. That's no question. Let's do the second one. Yeah, that is already here, right? Okay, remember, if you are given a data set, of course, you need to figure out now X bar, right? You could feed these values into your calculator and find the X bar, or you could do manually, like here, like here. Which formula they are using here? Could you tell me, any one of you? What is this formula? What's the formula we had at the beginning for sample mean X bar? Sample mean X bar is given by what? I need the answer from one of you, please.
I don't remember exactly how to say it, but it's the sum of all your values divided by n,
Oh,
correct?
very good. Yes, the summation of all the X values divided by N, right? This is the formula we have for the sample. Doing manually, add one by one all the data values and divide by number of data values. You have 36 here, therefore dividing by 36. Or feed these values into your calculator and find the one word statistics summarizing, then you will find their X bar. Either way. Okay, right? You know now X bar. So if you go through the problem, so again, we are talking about the population, the mean average, right? Um, okay, so, the standard deviation is given. Therefore, little sigma is 100. What else, little n, 36. And alpha, 0.1. And what was the claim? Do you know the claim? You know the mu, right? The mu is 515, right? It is coming from my null hypothesis. Okay, what was the claim? This school superintendent wishes to see if her students score significantly below the national average. The national average is now going to be kind of all the average. That is my population average mu. So she is suspecting, whether the mu is below the average, right? Therefore, my what? My null hypothesis is now less than because of below, right? So this is going to be what kind of test now? If you see the less than sign, it's going to be left tail test, right? So we have left tail test. So if you look at the picture here, we have the left tail. Right now, this area is going to be alpha, which is 0.01. Is that 0.01? No, 0.1, right? The 0.1? Yeah, alpha is 0.1. Now, if alpha is 0.1, area is 0.1, find the corresponding z value. Now you will get the critical value is negative because of left tail. So this is my critical value, right? Negative 1.28. But my test statistics is this one, x bar minus mu, plugging all the values. It says that it is 0.36, right? Negative 0.36. Negative 0.36 is somewhere here. My rejection region is here. So of course, my point is now, my test statistic is now falling in non-rejection region. Therefore, you cannot reject now your null hypothesis, right? So you can't reject. So do not reject. Do not reject H naught, right? Therefore, there's that. You don't reject this guy, right? That means what? That means you cannot accept now this guy. So your claim may be true, may not be true, but there is no evidence to accept your claim. So you can't accept your claim at this point because you do not reject your null hypothesis. Okay, that is why if you look at the summary, there is not enough evidence to support the claim, so you cannot accept the claim. Okay. Right, this is the one I just explained, right, about the p-value. Okay, so now we have 4 minutes, and I just want you to, fill out here. This problem is for you now. This blank, right? So let us set up first hypothesis, and you are going to tell me now, right? So what is H naught and H1? Yes. The researcher wishes to test a client that the average cost of the tuition and fees at four-year public college is greater than 5,700. She selects a random sample of 36 four-year public colleges and finds the mean to be 5950. The population standard deviation is 659. Is there evidence to support the claim at the significance level 0.05? Use the p-value method. Oh, now you have to use the p-value method, okay? So first let us set up the equation. Of course, she's talking about what? Average cost of the tuition fees. So again mu. But the claim was what? Her claim was greater than this value, right? Therefore, this is greater than 5.7. And she had 436 in the sample. Therefore, X bar, the sample mean is 5950. Standard deviation is 659. Alpha is 0.05. Remember now I have greater than sign, therefore my testing hypothesis is right tail. Oh, now which method we are using? P-value, right? Go back and check. What is the procedure to use the p-value? I explained somewhere here, right? If you want to use the p-value, first you have to figure out what? You need to figure out the test statistics, not the critical value. Now we don't want critical value. We are using p-value method. So you need to find the test statistics now, right? Okay, so I'm finding test statistics. What is that? The test statistics for this problem Z is given by X bar minus mu over little sigma over square root n. You know all the numbers. X bar is 5950. Then subtract the mu. Mu is 5700 over little sigma is 659 divided by square root 36, right? Find this number. 2.28. Okay, so I'm leaving this problem for you guys. So why don't you try this problem? Look at the guide I gave you when you use the p-value method. What are the things you have to do? Look at those. those steps and try to finish this problem. Anyway.